Hello, trigonometry. In this lesson today, we are going to be modeling the changing temperatures of a city over years by using our trig functions. Make sure you pay close attention to this because you're going to just essentially be doing the exact same thing I'm doing in this video as classwork, so you can always rewind and jump to a spot if you don't catch something when you're doing it on your own. So, my example. I'm going to be writing an equation that models the temperature of Sydney, Australia. So to do this, I'm going to go to a website called wolframalpha.com. All right, so I'm going to just type that in, Wolfram Alpha. It's an interesting site. It's a computation engine, kind of like a search engine, but for computations. It won't quite do all your homework for you, but it could probably do most of it. But why didn't you tell me that at the beginning of the year? All right, so as you see, it looks like a Google almost. It's got a search bar there. And so I want the temperature. I'm just going to type in temperature, Sydney, Australia. All right, hit enter there. It takes a little while. So there's some temperatures for Sydney, Australia right now, their highs and their lows. And what I'm going to do here, if you go down a little ways, you get a graph, sort of their daily temperatures right now. And instead of going current week, I'm going to go 5 years. For the past 5 years, what has the temperature of Sydney, Australia looked like? All right, take a look at that. Doesn't that look like that's a wave? That's exactly what we've been studying. And so we are going to use our sine and cosine to model the temperature here of Sydney, Australia. So I want a picture of that. So I'm going to use the snipping tool to get a picture of that. All right, paste that into the OneNote. Make it a little bigger. All right, there we go. All right, so if we're going to make this wave, here are the 4 characteristics we need. We need the amplitude, midline, phase shift, and the period. All right, I would recommend starting with the midline. So overall, we're just going to sort of take an estimate here. Oftentimes, the wave, it does get up to 80 sometimes, doesn't it? Let's call it 80. So I'm going to call the top 80. Oftentimes it does almost get up to 80 a couple of times. So I'm going to call the top 80. Now that's not the amplitude, right? It doesn't go up 80, it goes up to 80. Now where's the bottom of this wave, roughly? It looks like it's this right here, doesn't it? Somewhere in there. We can call this the bottom of our wave. So what number is this right here? Let's see, we're counting by 5, so that must be 55, it looks like. So the midline, we can get the midline from those two numbers. To find the midline, all right, you take the top plus the bottom, and you divide it by 2. You average it, essentially. That's how you can find the middle. If you can't see it and count it just by the graph lines, top plus the bottom divided by 2. So our midline is equal to, we said our top was going to be 80 plus the bottom 55 divided by 2. So let me pull up my calculator here. 80 plus 55 divided by, oops, that's not how you do it. You have to hit enter unless you use parentheses. Now I can divide by 2, 67.5. All right, so there we go. There is my midline, 67.5. All right, well, now that I have my midline, I can find my amplitude. So if the middle is 67.5, how far up and how far down are we going? Well, we need that distance from the middle to the top, or the distance from the middle to the bottom. How do you find the distance between two numbers? Subtract. So we're going to do either the top minus the middle or the middle minus the top. Either one of those will give us our amplitude. All right, so, oops, I don't need a fraction here, do I? So my top is 80 minus 67.5. 80 minus 67.5 gives me 12.5. So my amplitude is 12.5. All right, now my phase. So the phase you can sort of pick depending on where your starting point is. What starting point do we want to use? So we got years 2017 all the way up through 2021. It doesn't really matter which one you pick. Let's go ahead and pick 2020. That was a good year, right? Let's go with it. All right, 2020. That's going to be my phase. And this is 2020 to the right. All right, 0 is somewhere off over here, isn't it? The y-axis is way the heck over here at 0. We are 2020 years to the right. My period, what's the period? The last one here, what is our period? Well, how long does it take for one wave? Remember, the period is really easy if you go top to top. Bottom to bottom also works, or middle to middle, but top to top is probably the easiest here, and hopefully it's no surprise that the period is 1, right? We have summer every year, once a year. You don't get summer twice a year, thankfully. So our period is 1 year. Now, have you looked closely at this graph, actually? Cool thing about Sydney, Australia. Do you see how their highest temperatures are at the beginning of 2020? That would be January. Sydney, Australia is going through summer right now. They're in the southern hemisphere, so their seasons are switched from ours. So right now in Sydney, it is summertime. All right, they are in their high temperatures when we are in the low temperatures. Kind of cool that we're flipped. So when you choose your own city here in a minute, if you choose one in the northern hemisphere, your graph will be a bit different because summer and winter are flip-flopped. All right, but now we've got everything. Oh, no, we don't have everything because the period does not go in the equation, right? Remember, the period is equal to 2 pi over b. And we just found the period, right? So the period is equal to 1. All right, so we got to solve this equation for b. Thankfully, this is really easy. Put that over 1, cross multiply, and it basically solves itself because b is equal to 2 pi in this case. Why didn't that? There we go. Where's the 2? There's the 2. All right, so we got 2 pi for b. All right, now we can write our equation. So it is y equals, my amplitude is 12.5. Cosine or sine? Negative sine, negative cosine. What am I looking at here? So my starting point is starting at the top of the wave. That's a positive cosine. All right, so don't add a negative or anything. This is positive cosine. My b value is 2 pi. X, let's see, we are going 2020 to the right, so that is minus 2020. And then my midline, plus 67.5. There is my equation to model the temperature throughout the year, over the years of Sydney, Australia. Let's throw that into Geogebra to see how and if it matches up. I assume you could use Desmos here if you want as well, but I'm a Geogebra man myself. All right, so y is equal to 22.5 cosine of 2 pi. You can't actually just write pi in Geogebra, and that will take on the value of pi. It's kind of nice. 2 pi x minus 2020 plus 67.5. Now you might think, Bolt, where'd the graph go? Well, the graph is way up at 67.5. I got to zoom out. There it is. Let's stretch it a little bit here. All right, what do you think? You think that's going to match up for us? Let's see here. What does my graph go to here? The graph only goes down to 50-ish, so I only want to snip the actual graph here. Hopefully taking that much, and I want roughly 5 years, was it? All right, let's see if that matches somewhat decently here. Can I line up the y-axis there decently? Stretch that out. Hey, that's looking pretty good. Oh, let's make it a little about the same size there. That's looking like it fits pretty well, doesn't it? I like it. Maybe I'll put it down just a little bit there. All right, so that is what I want you to be able to do. You are going to pick a city, any city, except Fresno. Don't pick Fresno. Everybody would pick Fresno otherwise. Pick something else, all right? Almost anywhere in the world. You're going to go to wolframalpha.com, type it in, search for temperature and the city name. Just temperature, city name, and then do everything I did. Go back in the video, follow the video if you need to, but follow the same exact steps. And then you are going to put all your information in here, show your work, type things in, draw things in, whatever it takes. But I'd like you to do the same steps that I did. Good luck.